Example 144. In 1995, the American Cancer Society randomly sampled 1,500 adults, of which 555 smoked. In 2005, they surveyed 1,750 adults and found that 578 of them smoked. At the 5% level of significance, test the claim that the proportion of smokers in the population decreased over the 10-year period. What is the p-value for the test? Okay, so it's clearly a hypothesis test. They tell us to test the claim, and it's telling us to use the p-value as well. So it's a p-value hypothesis test, and they're telling us that we're going to do this test at the 5% significance level, and that it's to test the claim that the proportion of smokers has decreased over the 10-year period. So how are we going to say that claim in symbols? Well, it's a matter of comparing two proportions, right? So we have 1985 and we have 2005. So let's put the row 1995 symbol, and then we'll use row 2005 as the other symbol. Now, according to the claim, it says the claim is that it decreased over the 10-year period. So what does that mean? Would it have been higher in 95 or 2005? Well, if it's decreased over the 10-year period, it means that it would be lower in 2005 and therefore higher in 1995. So greater than is the appropriate symbol. From there, we're going to do the null hypothesis and the alternative hypothesis. So looking at the claim, we see the symbol implies the alternative hypothesis is the same as the claim. And then we see the null, and the null is going to be the opposite of that. So we're going to have to say less than or equal to for that one. Okay, so we've got that set up. Now from there, we're going to go and collect the data. And we want to be consistent. Again, if we use 95 first in our claim, we're going to use 1995 first in our data listing. So it says in 1995, they randomly sampled 1,500 adults. And then 555 of those adults smoked. And then it says that in 2005, they randomly sampled 1,750 adults. And 578 of those smoked at that time. They tell us the alpha level is 0.05. Okay, so that's our data, and as before, we want to do some extra calculations. So we need to have the p-hats for 1995, the p-hat for 2005, so we can do that first, or we can do this other p-hat value, the pooled estimator of the population proportion. So let's do the p-hat quantity first. Remember how that works. It's going to be to add the two x values together, and then we add the two n values together in the denominator, and we divide those two quantities. And this is going to give us our pooled estimator of the population proportion. Let's go ahead and do that now. Open up a parenthesis, do 555 plus 578, close your parenthesis, and then divide by another parenthesis, 1,500 plus 1,750, close that up, hit enter, and we get 0.3486 approximately. 0.3486. That's rounded off a little bit, but that's what it is. Okay, now from there we're going to get our q-hat value. To get q-hat, we simply do 1 minus the p-hat that we just found, right? And let's see what that is. So 1 minus that value we just had, and we get 0.6514. Okay, so those are our two values, right? 0.3486 and 0.6514. Those are our p-hat and q-hats. Now, we're going to need an extra pair of p-hats here. We need the p-hat for 1995. That's the sample proportion for 95, and we'll need the sample proportion for 2005. Okay, so for 1995, it's just a matter of doing 555 divided by 1,500, right? So x divided by n gives you your p-hat, and that's 0.37. And then we're going to do the same thing one more time. We're going to do 578 divided by 1750. So 578 divided by 1750, and we get the answer 0.3302, etc. So I'm going to go ahead and just call it 0.33. That's close enough. Okay, so there's our two p-hats. We have our pooled estimator of the population proportion. We have its complement. We're ready to go. Once we have all that written out, we can do our test stat calculation. The test stat calculation is not simple, though. Remember, it's kind of complicated. I'm just going to squeeze it in down here, so let's do it. We're going to need a z formula. The z formula is going to be a fraction. The fraction is going to be pretty simple on top. For this problem, to be consistent, we'll do 95 first. So p hat for 1995 minus the p hat for 2005. And then once we have that, we're going to divide that by the square root of. And in here, the square root is just the pooled estimator p hat times its complement q hat, and then times that 1 over, in this case, the n for 95. We'll just call that n1 plus 1 over the n for 2005. We'll just call that n2. So that's our formula. Okay, let's plug in some numbers then for this. The two p-hats here are going to be 0.37 minus 0.33, which is going to give us 0.04 as our difference. Then we'll take the square root of, and then we'll plug in these decimals, right? So the first one is 0.3486 times 0.6514, 6514, and then 1 over the sample size for 1995, which is 1,500, plus 1 over 1,750, the sample size for 2005. So it's kind of a long, drawn-out denominator there, but that's all the numbers we need. Let's go ahead and take care of that calculation then. So the top is 0.37 minus 0.33. Close it up, divide by, then take your square root, and put 0.3486 times 0.6514. Now here's the part where you need to put an extra parenthesis, so you're going to open up a parenthesis and do 1 divided by 1,500 plus 1 divided by 1,750. Close up that parenthesis. And you close it up one more time for the square root to end, hit enter, and you get 2.39 approximately. And we want to round this one off to 2 decimal places because the problem asks us to find the p-value. So 2.39 is what we'll use. They ask us to find the p-value, so we're going to need to have 2 decimal places to use the z-table for this problem. All right, so now that we have that, let's go ahead and draw our bell curve now. To get the p-value, you need to draw a bell curve. And remember, we don't do anything else except for put that test stat on the curve where it belongs. In this case, 2.39 belongs on the right-hand side because it's bigger than 0. So I'll draw a line where that's supposed to be on my drawing. And then from there, I look at this claim, not the claim, but rather the alternative hypothesis, and I see that it's a right-tailed test. It's indicating a right-tailed test here. If it's indicating a right-tailed test, it means I need to find the area to the right, and that will be my p-value, right? So remember, for right-tailed test, you find the area to the right of your test stat. Even if your test stat was on the left-hand side, you'd still find the area all the way to the right, and that's your p-value. So we need to figure out what that area is. So let's go to the z-chart. We're going to look up 2.39. That'll give us the area from here to here. Then we'll subtract that result from 0.5 to get the tail area, and that will be our p-value. All right, so let's go take a look at that. Okay, so we're looking up 2.39 on our z-chart. So let's go to 2.3 first along this column. So I'm going to move my table up till I can see 2.3. Okay, so now in the 2.3 row, we're going to go over now to the 9th position, which is the very end, all the way to the very end, and we see the answer 0.4916. 0.4916. Okay, so we found the answer to be 0.4916. And because that's the area there, we're just going to do 0.5 minus that to get the leftovers, so it'll be let's just write it out, 0.5 minus 0.4916, and then of course you'll see that you get 0.0084. So less than 1%. So our p-value then is equal to 0.0084. Now how does that p-value compare to alpha? Well, I would say that that is less than our alpha of 0.05. And because of that, we're going to say the p-value is small. And because it's small, it's going to cause us to reject the null hypothesis. So we're going to say reject the null. and therefore support the alternative HA. All right, from here, we look at the claim and we say, hey, the claim is the same as the alternative hypothesis, so we should support it. So we're going to support the claim then. So our final statement is the sample data supports the claim. The sample data supports the claim. And of course, what is that claim that we're supporting? It's the claim that the proportion of smokers has decreased over the 10 years after 1995. So from 95 to 2005, the proportion of smokers has gone down.